Cool. PyCon, Python and flies. Marc-André Lemburg.
Hi.
Give him a big hand.
Thank you. So I had a talk yesterday about Python and performance, and I left out some parts because I thought I wouldn't get 52 slides into my talk time. So this is about Python and flies. So what's the objective? You're trying to store lots and lots and lots of objects in memory. So how do you do that? Well, first of all, you could use the simple naive approach. You simply don't care. You just create all the objects in memory, and then the memory just overflows, and you're stuck with a memory error. Now, that would be this kind of approach. So you just generate you define your objects, you put all your objects in memory. This example with 1,000 objects uses 353K. You can do a little better if you use new style classes and use objects. It goes down to 345K. And then you can remember your CS course from university, and you can use the flyweight pattern. How many of you know the flyweight pattern? Wow, not a lot. So the idea behind the flyweight pattern is that you try to only store the data that corresponds to your objects, and you don't store anything else of that object. And whenever you need an object of your collection there, you recreate it on the fly using that data that you stored. So I tried various different ways of doing that, and the most efficient I found was subclassing from a Python list. And then in the various entries that you have in the list, you store just the data of your object, and then you have a method, say getFly in this case, that then recreates your object on demand. And so if you do some timing, this is what you get. First of all, it's faster than the original implementation. Well, just a little. But most importantly, you just use 80 kilobytes for storing all your data. And you still have your 1,000 objects in memory and available to you if you need them. So that's a reduction by 76%, which is a lot. So you should definitely try to use this pattern if you have lots of objects to store. Now, there's an even better way to do this, and that's using slot attributes. And I asked the question yesterday, how many of you know slot attributes? More than the flyweight pattern. That's interesting. So if you use slots, then it gets even better. You can forget about all this fly storage stuff. You can forget about the flyweight pattern itself. You can just use regular Python objects again and store them in a regular Python list. And it'll just use 72 kilobytes in memory. And you still have full control over everything, and you don't need the CS course. So this is the way to go. Use slot objects, slot attributes. Right, and the implementation is up on GitHub if you want to take a look. It's in one of the performance tests that I wrote. And all the other stuff that I presented yesterday is in there as well, so you can have a look at all the performance on your particular platform if you want to. That was it for the lightning talk. I still have a few minutes left. I got a question yesterday in that talk about the performance of exceptions in Python. And I showed you that using exceptions can be very, very slow in Python, especially if you trigger the exception and you catch it in Python itself. And the question was whether it makes a difference whether you have a very deep call stack in your exception or whether you just have a very shallow one. And so I wrote an additional test for this, and here's the finding. So the difference is next to none. So it doesn't really make much difference whether you have a deep call stack or not. So that's the answer to that question. And I think this area is something that we need to address in CPython a bit. Maybe we can do better than this, because the difference between triggering and not triggering is just enormous. Thank you.
Okay, Daniel, can you please set up your system?